Now, let's try to look at Merton model. This is primarily targeted towards finding out the credit risk. It is a credit risk model. It is majorly intended to model the probability of default. And a few assumptions that it goes with is a company for which we are interested in modeling the credit risk. It assumes that that company has issued both capital in the form of equity as well as debt. So ET is the value of equity at a point T, DT is the value of debt at a point T. Now these two put together at any point will form the value of the firm, which is equal to Vt, or in some cases it is denoted as f of t. At time period t, we are looking at the value of the firm as f of t or Vt. And this f of t changes because of the various actions the company typically gets into. Lot of corporate activities the company gets into, this f of t is going to change over time. And here one more assumption that is brought in is, yeah, though the company has raised equity capital, it will not issue any kind of dividends. It will not pay any kind of dividends on it. And the debt, whatever the company has issued, it is more in the form of zero coupon bonds, which means no intermediate payments would be done in the form of coupons as well. Coupons and dividends are typically not paid. That is one major assumption that we are going to look at. Then what we are seeing is, okay, the total value of the firm, some portion of it which is in the form of a debt is in the form of a zero coupon bond with a maturity which is equal to some t, and the remaining portion of it is constituted in the form of equity. So this the debt part is primarily a kind of a zero coupon bond, let's say of worth d of t, should be repaid at time period t. And it also is assumed that at final point t, whatever is remaining after paying to the debt investors, that would be paid off to the equity investors. Whatever at the end of the period, let's say I am interested in finding out the credit risk for a 3-year period, then what we are typically looking at is the a bond, a zero coupon bond which is maturing in a 3-year period, being represented as dt. Whatever is the equity that is remaining at the end of 3-year period, it is paid off to the equity investors in the form of dividend, and the company is wound up. That is one more major assumption that is going as a part of the design of this Merton model. And because of all these assumptions, one more thing that is coming out is, at that point in time t, f of t represents the value of the firm at that maturity point, f of t represents the value of the firm, d of t represents the value of debt, and e of t will represent the value of equity. Now, whenever I am seeing that the value of the firm is less than the value of the debt, that is what is associated to default. That is when I can say that the firm is going to default, because it is not able to pay the amount that it is due to its debt investors. And we need to know that is f of t, d of t is a constant which is known in advance, because that is the amount of loan that has to be repaid by that particular date. So whenever I am seeing f of t is less than d of t, or probably let me call it simple d, f of t is less than d, which is a promised debt repayment at time t, we say that this company is going into default because the debt investor is going to get only f of t. He is not going to get the whole d. He is going to get only f of t, and equity investor is going to get 0 in this case. Now here if I am looking at the scenarios, if f of t is greater than the debt investor is going to get his complete loan repaid, which is d, and the balance f of t minus d goes to the equity investor. Whereas if I see f of t is less than d, the debt investors are going to get only f of t and equity investors are going to get 0. With this kind of a situation, I can very well say from the equity holders perspective, right, the equity holders value, you could clearly see that it is equivalent to a European call option, right? If I have to compare this concept with respect to Black-Scholes formula or with respect to the concept of an option, I can very clearly see that the value of the equity is similar to a European call option on the value of the firm, right? European call option on the firm or the assets of the firm with a maturity period T and a strike price equivalent to that zero coupon debt that has to be repaid at the point T. This is what we are calling as the Merton model for credit risk. The Merton model simply assumes that the value of the equity is similar to a European call option on the assets of the firm with a maturity period T and a strike price equivalent to the amount of debt that needs to be repaid. Right? That is how a typical Merton model comes into a pricing of a bond subject to default risk. Now, let's try to take a very simple example. Let's assume that a company ABC has issued zero coupon bonds, right, with a maturity of 4 years. And let's say the debt is $120 million. They have issued 4-year maturity zero coupon bond, which at the end of 4 years, 120 million needs to be repaid. Now, if I have to look at the value to the equity at time t, right? If I am interested in finding out the value to the equity at time t, it is nothing but the maximum of f of 4 minus 120 comma 0. This is the benefit which the equity investor is going to get after 4 years. Right? If f of 4 is greater than 120, he'll receive the difference. If f of 4 is less than 120, he is going to get 0. But if I look at it from a debt investor's perspective, probably it is like he is going to receive minimum of f of 4 comma 120. Either he will receive f of 4 in case f of 4 is less than 120, or he will receive 120 if f of 4 is greater than 120. Which means in other way, I can also write this as 120 minus the maximum of 120 minus f of 4 comma 0. Look at this. If f of 4 is greater than 120, then this number is negative, right? If f of 4 is greater than 120, This number is negative, this is 0. So maximum of this is 0, so he is going to receive 120. If f of 4 is less than 120, of course this number is positive. 120 minus that positive is going to be same as, so in that case it is going to be 120 minus of 120 minus f of 4, in which case it is going to be f of 4 only. So either I can write it in that way, or I can even write it as f of 4 minus maximum of f of 4 minus 120 comma 0. Now if you see, if f of 4 is greater than 120, then it would be f of 4 minus of f of 4 plus 120, which means the debt investor is going to get 120, and if f of 4 is less than 120, is going to get f of 4. So either of the ways I can very well write the value of the debt. So one I can write it in a minimum form, minimum of f of 4 comma 120, or I can write it with respect to the debt minus maximum of debt minus the value of the firm comma 0, or it can be written as value of the firm minus maximum of value of the firm minus the debt comma 0. Different ways in which the same scenario can very well be expressed, right? And so in a way you could clearly see that these are the different ways in which I can do the pricing, in which I can find out the payoff at time t. Now, if I want to find the price at the time 0 for the same, it's as good as the expected value of the minimum of f of 4 comma 120. I want to discount this. I want to discount this by e to the power of minus 4r. So this is what I can typically do, right? E to the power of minus 4r, I want to discount it in this particular manner. And the expectation when I am doing it by e to the power of minus 4r, it is primarily a risk neutral measure, because I am discounting the expected value of the future payoff by the risk free rate. So this entire value should be equivalent to f of 0 minus c, which is a typical value of the call option, which is having call option which is having a strike price of 120. So this entire thing probably will become 120 e to the power of minus 4r, that is the present value, minus the price of the call option. Now from here I can find out the price of the call option quite comfortably. This is what is a typical mechanism that goes into the pricing. Now let's try out something else. If I say for the same company which has issued a debt D equal to 120 million, time period of 4 years to maturity, and on this if I say the current gross value V of 0, if I say is equal to 180 million, right, the current gross value of the firm is 180 million. At the present, the continuously compounded risk-free rate of return is 2%, and the credit spread at this moment, let's say, is 4.5%. Now from here, I can find out the price of the bond, right? If I want to know the price of the bond on a risk-free basis, or probably the price of the bond without the option. Without the option, if I want to look at from this data, I can find out the typical price of the bond as 120, which has to be paid at the end of 4 years to the power e power RT. So the R in this case will be 2% risk free and 4.5% for the credit risk that is present in it. So 6.5% times 4. So if I look at it, if the same example, let's say, let me take it into a spreadsheet to typically explain the entire process. So I will talk about a bond which is having a debt of 120 million, the time period of 4 years to maturity, the risk-free rate of 2%, credit spread of 4.5%, and currently the value of the firm, let's say, is 180 million. Right? Now, first thing, if I want to find out the price of the non-option bond, the price of the bond as of today, without looking anything into the option. So it becomes 120 into the e to the power of minus R is both risk-free rate of return along with the credit spread, e power minus R times T. So working out that the price of the bond is around 92.52 million. Now, if at all I have to look at it with respect to the call option on this, right? I have to look at, let's say, the price of the call option, which is the worth of the equity is looked at as a call option on this particular bond. So from this perspective, I'll try to use the typical option pricing formula. So for this, let's say I'll go with the volatility. Right, I'll try to go ahead with a volatility, let's say, of around 20%. So in this case, I'll compute the D1, which typically comes out as log S, which is the value of the firm, divided by X, which is the strike price, which is equivalent to the value of the debt, which is going to be maturing, plus the risk-free rate RF plus sigma squared by 2 times T divided by sigma into square root of T. Sigma into square root of T. So this is giving me my D1. D2 is working out to D1 minus sigma into square root of T. This is coming out to D2. Then N of D1 comes out as norms dist corresponding to D1, while norms dist corresponding to D1 working out to 0.92. N of D2 comes out to norms dist with respect to D2, so working out to this particular number. So there is N of D1, N of D2, and from here comes the price of the call option, the worth of the call option here coming out to price of the call option is S naught, which is nothing but the value of the firm, times N of D1 minus X by e power RT. So which is the value of the debt divided by e power RT times N of D2. So this is coming out that the price of the call option is 72.26, which is the value of the equity through this mechanism. So through this option mechanism, the value of the bond, if I am looking at as of today, through this mechanism, if I am looking at the value of the bond, It is like 180 minus the value of the call, which is around 107. Now, all I want to look at is what is the volatility that is present here, right? What is the kind of volatility that has to be present in case the value of the bond should be equal to 92 itself? So, which means the call option should go up, the value of the bond should come down. So, what my intention is make sure work it out in such a way we can work it out in such a way using the what if analysis. I want this value of the bond to exactly 92.5262 by changing the volatility level, which has worked out that the volatility has to be somewhere in the range of 40.23%, so that the value of the call option is going to be 87.47, which is nothing but the worth of the equity, and the value of the bond then in that case is going to be 92.52. Or I could have started, once I have got the price of the bond to be like this, the difference is the value of the equity, and taking that to be the value of the equity, adjust this volatility, which is what will give me the implied volatility in the process, right? So that is the way out of determining the implied volatility of the assets in case we know that the price of the bond is going to be something and the value of the assets are known at the current situation. And an extension to this is finding out in this model, how do I find out the risk neutral probability of default? We have seen that the risk neutral probability of default, which is nothing but Q of default, is same as what is the chance, what is the probability that F4 is less than 120. So which is nothing but 1 minus of n of d2, which is n of minus d2, or 1 minus of n of d2. So in this case, I can very well look at, this is my n of d2. So the probability of default is going to be 1 minus of n of d2. So in this case, there is a chance of 42% where there is a probability of default. So from the Merton model, we can very well compute the value of the debt, the value of the equity, and finally go even towards the calculation of the probability of default, right?